We're back again, and today we're going to talk about mounting the solar system. We talked about last week. We talked about the electrical components of it, and the electrical engineering parts of the solar system. And today we're going to look at how to mount it and how to mount the system. Look at different mounting options. We're going to go outside actually and look around a little bit on the property too. So, but before we do that, let me open us with a word of prayer. Lord God, thank you for this morning, the opportunity to be here and to look again at solar systems and to understand how to mount those systems properly, or to learn about that some more. So pray you be with us as you promise, and guide, strengthen us, and fill us with the Holy Spirit. In Christ's name, amen. So, you got to change the source of that one. I gave you an outline. One of the things that if you recall, our the system that we're talking about here is 14 panels, 14 solar panels. And I know Jesse's got his tablet with us, and you might have the ability to calculate this. But from the last time, I think we handed out the solar system sheet, or the solar panel information sheet. And on this, it gives dimensions of the panels. And these are in metric. And so the width of these panels is 992, and the length is 1956. So that's in millimeters. Okay. All right? Yeah. So what is that in inches? If somebody maybe you can convert for us, Jesse, if you can get online or whatever, find the conversion for that. But 992 millimeters wide by 1956 long. So what's going to be important is, if we have 14 panels, we're going to have 2 rows of panels, 2 strings, and so we need to know how to mount those and how much space it's going to take up when we look at our mounting systems too. So while he's figuring that out, we'll start to talk about some of the things. Well, site selection. When mounting solar panels, one of the first things you got to think about is where you're going to put them. The site. Where are you going to put these panels at? Now, in a residential solar system, traditionally the simplest and least costly way to go is to mount it on the roof. To mount it on your roof of your house. And so our roof here, we could mount solar panels on it, and to a great extent, the location isn't too bad, because why do you think this would be a good location on our house, the way our house is situated? Yeah, go ahead, George.
Facing south.
It is generally facing south, yeah. Our house is not quite, and you'll see in a minute when we go outside, we're facing southeast, but we are generally facing south, which in the northern hemisphere tends to be a pretty good way to face your solar panels on the roof. But there's other considerations too, and so sun exposure is one consideration. The other one is shading. I think last time we talked, Mr. Martindale mentioned about shading, that if you shade a solar cell, one of the cells on a panel, you can start to take out a whole number of things. You can take out a whole string of solar cells that are connected together, or you can even take out a whole solar panel by itself out of the system. And if you take out, depending on how you hook it up, if you take out a solar panel, you may take out a whole string of solar panels too, so it would not be producing energy. So shading is important. So if you have a big power pole or a big pipe or something, and it shades in just the wrong way, it could knock out your solar system from producing energy for a period of time. So shading is a huge concern, or huge consideration when putting in solar systems. And we're going to look at something that helps you determine the shading and how it would impact your solar system a little bit. So you kind of start by looking at a roof system, and that's kind of what we did too, was considering putting on the roof system here. Like I said before, I'm going along the outline. Why the roof? Well, one is the least expense, most likely, generally easier installation on the roof than other solutions. There's complexity. Why not the roof? Well, shading could be an issue. Roof penetration, in other words, we have a steel roof that we put on a couple years ago on the roof, And so if we're going to put something on the roof, obviously we're going to cut holes in the roof or drill holes or put screws through the roof or whatever. Whenever you do that, there's a possibility of what?
Leakage.
Leakage, yeah. So and we don't like water to come in where it's not supposed to. The other thing about roof systems, in general, we're talking about a fixed system. It doesn't track the sun. So now that's not always the case. You can set up tracking systems on a roof too, but in general they're not going to track the sun as it moves from east to west, or as it moves over the course of the year, north and south. Right now our sun is getting higher in the sky, if you will, from our perspective, as the Earth's tilt as we rotate around the sun. And so the sun is now crossing the sky at a higher angle. And our solar panels, if they were tilted towards it, like we were talking about down at the solar plant tour, they would capture more sun. What about ground mount? Ground mount is, there's more flexibility in determining the location as long as you have the space. We have more land here area than maybe a yard would have, a house yard, but we have, when you have land or you have you can determine the space. You're not fixed by the house anymore, obviously, or the face of the house. It also makes tracking possible when you do ground mount systems, or a lot more easy to do tracking systems in either one of the two cases. Why not ground? Well, it does add expense, depending on the ground mount solution. It could be unsightly. You need a lot of area, and it may be risky for the panels. Obviously, if something's on the ground or within, it could get hit by something. It could get shot. There's people who get, that have solar systems out, and somebody decides to take a pot shot with a 22 or something and put a hole through a panel. Obviously, that's going to damage it. Run into it with a lawnmower or whatnot. There's different things that can happen to it. Types of mounting, there's generally, before I do that, maybe I'll show some pictures of different types of mounting solutions. These are ones on roof systems. These are on-roof type mounting solutions.
So would you want to keep the solar panels off the roof so that not too much heat from the building would make them?
Exactly, that's exactly right, David. Plus you need some mounting hardware, so it's kind of hard to mount them exactly right on the roof, but right. Remember what we were talking about in the plant, the cooler the panel is, the more productive it'll be. So there has to be an air gap. At the same time, a roof mounting system, one of the things that is most important whenever building anything outside is wind load, snow load, things that go against it, push against it, or pull against it. When when a solar panel is mounted really close to the roof, there's not a lot of air, wind possibility of grabbing that panel because it's not exposed to the wind. Okay, so close is good from that perspective, but also heat buildup too is the downside if it's too close. But excellent question. So these are different systems. Obviously, the ones with tile, they're probably out west somewhere. They use tile roof a lot out west where it's hot and so forth. Other types of ground or roof mount systems like this that are on flat roofs. Commercial buildings a lot of times are flat roofs, and so they have. Here's one with snow, a big roof. I like this one. The edge of the roof, the victim fell off. Apparently, this is something to do with someone who got injured while working on a roof, unfortunately. I don't want to laugh at somebody, but sadly enough, somebody... So you notice when you see solar installers, most of the time, I don't know that these guys are wearing it, but most of them are harnessed on so that doesn't happen. But, and then you can see the types of things that you have to do with shingle roofs. You have to put your mounts on and then have them weather underneath the shingles. That's why tin is a little bit more difficult. With shingle, at least you can put something on the roof and you can shingle around it, and so the water will. That's kind of a cool design there, isn't it?
Yeah.
I don't know how you get triangular solar panels, so that's kind of interesting, but looks nice. There's a huge one on a barn. That would produce a lot of energy, wouldn't it? Yeah. So, and then ground mount systems. Here's one that's wood. This is going to be very familiar to us here. Here's one with, a lot of them are done with, I think the ones at the solar plant tour, they were done with posts. They had posts. So that's usually galvanized pipe of anywhere from 2 to 3 inches in diameter. So it's good sized galvanized pipe. Wood structures.
So are you guys planning on doing both roof and ground, or?
No, we're not. We're just going to do a ground mount, and we'll see why outside in a minute. But yeah, we'll just be doing a ground mount system. Yeah. Sometimes ground mount systems or other systems are done with just a weight. Here's the weight.
That makes sense.
Yeah. Now, Mr. Martindale said that the wind load they have to calculate these to withstand is 75 feet per square foot. And that doesn't sound like a lot, maybe, but when you take a 10 by 10 area, it's 100 square feet. That's 7,500 pounds of pressure that it has to withstand. That's a lot of weight. That's a lot. You're putting a big sail up. And the way to calculate it is if you look at this. Now let me get a bigger picture here once. Okay, this one here. The way to calculate the wind load, he said, was if you measure from the top edge of this straight down to the bottom here, that essentially makes a rectangle. So you don't worry about the angle, but you measure from the top down to where the bottom is like this. So this is the height and then the length, and so that would give you your square footage, and then figure times 75. So that the ground mount system then has to be able to hold 75 pounds per square foot. Yeah.
So then the steeper the angle, the more wind load.
The steeper the angle, the more wind load, or the less angle, the less the wind load. That's correct. And the higher up, it doesn't really matter necessarily, but the bigger it is, it matters. And then, what essentially ends up happening is, and it's this is what you gotta love about engineering, is when you design the posts that go on the ground here, you sink these posts in the ground, and so most posts, whenever you sink something in the ground and build it in the ground, you want to get below frost level. In our area, generally, building code requires 4 foot or deeper for things to be sunk into the ground. That way, when the frost comes, it doesn't move it. The frost is above that level, and so the ground moves, but this is anchored below, and so it can slide up and down along the post. But then what ends up happening is that you can figure that this post that's in the ground, and at the bottom of this post is probably some kind of disc or something that's down there. It's not just the pole, because the pole isn't going to do anything but slip right out of the dirt, so there's got to be something there. And here's the interesting thing. If you take, let's say it's a 12-inch round circle at the bottom of this, 4 feet deep. And if you think about that circle, when the wind is pulling or pushing on this thing and it's pulling up on that, you can actually calculate, you can figure that disc at an angle heading towards this front one, towards this front post right at ground level, the angle from down here 4 feet that way, 12 inches wide by however far that is an amount of dirt. It has weight. And you're using that as counterbalance. Because this is the pivot point up front. If I'm pushing from this way, it'll want to turn around there. So this post isn't going to keep me from, it's not going to hold it from pulling out of the ground. It's this back post, so these back posts. So if you calculate all of those posts and all that dirt, that weight has to be greater than whatever the poundage of wind that's pushing against it, if that makes sense. So that's what's going to happen, is it's going to push against that. And then the type of soil would matter too. Because you'll not only get the weight of that soil, but also its friction, its holding. For instance, a sandy soil, something could pull through it a lot easier than what we have. Clay rock soil that we have, you'll find out if you come along next week to help a little bit, you'll find out how fun clay is anyway, so it doesn't move very well. But anyway, that's basically the idea, is the wind load can be dealt with by that. Does that make sense? No. So, ground mount system. Now the other one that we saw down at the solar plant, monopedestal type mounts. They don't always have to be tracking, but often they are when they're done on a single pedestal. Oops, I didn't want to do that. But, they're tracking types. But They are really cool looking. However, like we found out from, what did we learn from the plant manager, from Brent? They're super expensive, and then what did he say about how did he like them, effectiveness or whatnot? Did he?
Yeah, like,
I think he said they were effective, but you need money up front in order to get that effectiveness.
He also said he didn't like them because there's electronic motors that don't last as long as the panels. That takes more repair work.
Yeah, all mechanics.
So you're gonna have to buy those replacement motors.
And you need way more room because they move so much and you cast such a big shadow.
Right,
You need a
right,
lot more room.
right. So the next pedestal has to be far enough away that you don't shade from your solar panels with the other one, right? Yeah, and of course, and then they could change the way that they're tracking. In other words, they had the eye, and he said sometimes the panels on a dark day they're looking around for the sun, they're moving around doing nothing because they can't find the sun. But you can change that, that's easy enough to change that by some other method. But they are pretty cool looking. But cool looking and money is two different things. You also don't have to, you don't have to have a tracking one, you can have a fixed one too.
yeah, that would make sense to me, it's just a fixed one.
Have a fixed one, right?
If your house were to shade or something.
Sure, yeah. And again, you don't have to necessarily go in the ground with some big concrete as long as you've got the counterweight. I've seen these mounted on roofs with weight, but not drilled in and so forth. But again, you gotta have the amount of weight to withstand the wind load and so forth. And then those tracking ones, you can have single axis or dual axis. And I don't know if we talked about it down there, but in the case of a ground mount system, how could you make a single axis? And what do I mean by that? What would a single axis tracking look like on a ground mount, fixed ground mount like this? What would that look like?
Well, if you had pieces that you could slide into each other for the different seasons,
Okay.
and you could latch them.
And so then excellent. And so then what would you do? Let's say if you looked at something like this, you maybe have this as a pivot point, and then this go up and down. So you can move right. And like you said, you can have, like this could be two poles or something that slide, so you can move it up. So at spring solstice it's at one angle, and summer it's down lower, and then back at solstice, and in the winter it's really like this. Sometimes I read up on it too that a lot of people that do that do it about 4 times a year is all. So you got winter position, summer position, and then solstice position is not solstice. Yeah.
Spring?
No, equinox. Equinox, excuse me. Spring and fall equinox would be somewhere about the middle. So, for instance, here for us, 42 degrees is our latitude. So at spring and fall equinox, 42 degrees would be perfect. Summer, you'd have a lower angle, and winter would have a steeper angle because the sun is going to be way low on the horizon. So, but yeah, you can do that. I looked into it, and it looked to me like what I could see is something like that probably adds about 8% efficiency or something. So you gain about 8%. And so I just decided instead of doing that, to gain 8% wasn't there. Full tracking adds a lot more, but single axis doesn't add as much. So, all right, cool. So Jesse, what'd you find out for the dimensions
So
on
you
that?
want that from millimeters to inches?
Yeah, so I want the width, 992 millimeters and then 1956 millimeters.
Okay, so for 992, it's 39 point. Yeah, it's 39 inches.
39 inches wide.
Yeah.
Okay, all right, so 39 inches wide.
And then for
Right.
1956, it's 77 inches.
77. So about 39 inches wide and 77 inches tall. So pretty good sized panel. And we need 7 of those in a row, another 7 in a row. And we're going to put them in basically 39 inches side by side and then 77. So the 2 rows are going to be the tall ways. So what would be the overall dimension of that, Jesse? So if it's
39 times
7. And then the 77 times 2.
So.
And then put it into feet if you can divide by 12.
Right. And the height, how many was that?
2 times 77.
Right.
Yeah, it's not this. It's 6.
I was like,
Yeah, it's yes.
273 by 154. So, yeah, 22, 75, and then 12 feet, 8.
Okay, so 12 feet by 22, 23 feet long. So pretty good size, right? So this room here is 11 feet or so a little bit taller than this, and then 22 feet is about here to the back wall. So pretty good chunk of panel. So what I like to do now is why don't we go outside, and we're going to look around a little bit outside at the roof, and we're going to take this device out there called Pathfinder, and then look around at the different places, maybe on the roof, on the ground. So this is called a solar Pathfinder, and maybe one of you can come up here. Well, I'll show you from down here. Let's do it down here. You come on over here and take a look at this. So what this device does is it's got a compass on it, so we'll get that facing south. So we know there are a roof orientation is not quite south, but that's not the end of the world, but it is an issue. And then I'm going to get this level here with the center level. So this is a really simple device, and if one by one you can take a look and stand over. But what we're looking for, I want you guys to come around this way a little bit, because you're going to look for really kind of a simple, easy device. But basically what's going on is if you stand over this and look at it, you'll be able to see a reflection on here of different things. And the chart here, if you look at this chart, it says December, January, November, so forth. Those are the months of the year, and here's the time of day. So what we're going to see is if you look at the reflection and look through to here, we're going to see during the year and what time of day would there be something that could cast a shadow at this point right here. That's basically what you're doing with this device. So, and it's pretty slick device. It's called a Solar Pathfinder. So I think it's pretty slick because it's so cheap, and yet it's pretty amazing. So for instance, here is and I'll let you, here is the shed that's right here, and here's a tree over here, and they are casting a shadow in the months of December, January, November, February, and October up until 9 a.m. See that right in there, 9 a.m., right? Mm-hmm. So at noon, the shed is not casting a shadow on any months right here. So if you look over top of that, go ahead and see over top of that and see if you can see. Go ahead. Come here, look over top. You see the reflection right there? See there's other reflections like over here. Like if that was a tree, he'd be reflecting up until September, 2 p.m. in the afternoon. All of those months he'd be covering the solar panel right there at that time. Take a look at it and see what... Can you see the flagpole in it at all?
a little bit, but just barely.
Okay, but it would cast a shadow. It would cast a shadow at some point. When would it cast a shadow? Can you...
5 a.m.
So 5 a.m. right when the sun is real low.
And like June and July.
June and July, okay.
And May.
Yeah, because the sun in the winter comes up over here, and in the summer comes up over there. So when it's over here, it's going to track around like this. It's not going to cast the shadow from this thing over here, right? So that's how this thing works pretty well. So we would get some shadow. Now, I don't think what's showing here is too well these trees. Because if you think about it, in the winter, and actually the shed is casting more shadow, but those trees, here's a tree right here. That tree right there, I think, is this one. He casts a shadow starting, so for nearly 4 months out of the year, he casts a shadow from 1 o'clock in the afternoon on. So for 4 months out of the year, for several hours of the day, he would cover up the solar panels.
It's not very effective.
No, it's not real good right there, is it? So, and that was what, so this doesn't quite face south. It has a lot of shadowing possibilities, and so it wasn't necessarily the best location. And then penetrating through the roof wasn't something I wanted to do. Now, our land, this tree line right along here is east-west. So that's the south tree line, right? And our land is this triangle. We're going to walk around once, and you guys look around, we'll get around the other side so we can see the whole property a little better. And you guys kind of think about where would be a good spot if this isn't going to work for us. And I thought about, well, maybe maybe this shed on the other side. Well, what's the problem with that? Too close to the tree line. Because I wouldn't care so much if water leaked in the shed as much as in the house. You know, I can handle that. But we'll go and look around a little bit. Let's go over this way. Might be another spot to go. And when you do ground mount systems too, the consideration is the further you get away, the bigger the copper you gotta have, because you're gonna have voltage drop at some point. Now you can get quite a ways away and you won't have too much voltage drop on AC, but so we could put it here, right? But what about the house? Okay. What else might it be with the house? Look at the big window. So here I have, how big is it? 22 by...
Oh, yeah.
It would be what?
There would be glare.
Well, not only that, it's an eyesore, isn't it?
Yeah.
You know?
Mm-hmm.
It's,
Yeah.
it's a downboard chair. So,
What if you were to put it down by your wagon?
out there, okay. And why would you pick that spot?
Well, it looks open.
Looks open.
Facing
Like-
south.
Certainly can face south. There's no obstructions, really. I mean, maybe we'd have to check with the Pathfinder, those trees, those maple trees there. They might be there. Only trouble is that's my pad for a greenhouse for the future.
Well, I mean, you could use it for your electricity pad.
Yeah. So that wouldn't be bad. It's a nice flat pad, a great spot, but I want to put greenhouses there eventually. That's why I flattened it, but that's a pretty good spot.
So then what about on the other side of this tree?
On the other side of this tree, down in this open spot. The septic, yeah. Okay, so we're a good ways away from the tree line, right? And well, that's a pretty good spot. Anywhere else? And anybody else is thinking? By the way, while we're looking. You know, I mean, this is a good area in here because there is absolutely nothing shading it, but it's got two problems. One is it's right in front of the picture window, so it's unsightly, and then it could shade the garden.
Yeah.
The solar panels themselves could shade the garden because we have a massive space, right? 22 feet by 12. That's huge.
Yeah.
Come on over and take a look at any obstructions and tell me a little bit about what you see in there that might be.
There's barely any trees like there's some trees up in November and January in the mornings.
Yep, you can see those, right? Yep. One big maple tree here, this big sucker here, he does shade here a little bit at 8 o'clock. He does cut quite a bit there, doesn't he?
But it's kind of
But it's open a lot more. There's a lot of open space the rest of the time, right?
especially at the heat of the day. It's
Yeah.
all open.
At the heat of the day, yeah. And if you,
it looks good.
it's another one over here. That tree there, it looks like. That one's dead though. Actually, I'm gonna cut him down. He's dying anyway. This guy. Look over. What's that?
Just cut down all.
Then they're out of the way, right? Look over where Jesse's standing, right? Actually, if you move a little bit this way, Jesse, look at this tree over here. You see him in there?
Yeah, he's shading.
He's quite a bit. But again, this is a dying maple tree. He's coming down. He's dying anyway. And then you got to look carefully sometimes. Look at it. Can you see the power pole in there? You got to look really carefully. See the power pole?
Oh yeah.
Yeah, you can see him. So he cut a little shadow, but not
much.
not too bad. Yeah.
A little bit better.
And actually, I'll give away a secret. This is a spot we chose. Right here.
Kind of hard to tell.
Well, huh?
Kind of hard to tell.
Kind of hard to tell, really, isn't it? That we chose. Yeah. So,
So, because the sun, purple will cast a shadow because the sun actually comes over here.
in the summer, that's right, David. If you're looking south, that sun is going to set over there in the summer. Come around, he's going to set over there in the summer, right? And then in the winter, he's going to be down there, and he's going to come up this way, and he's going to go that way, right? So it is kind of hard because he moves a lot. So, like this pole here, and that's why this thing is shaped the way it is to catch the months and stuff, which is pretty cool.
Yeah, it's really cool.
And if we back up a little bit into this area, we're going to about the center.
The pole's kind of out of the way.
Right, you get less. Okay, so now what do we got here? Boy, we got that maple tree. You can really see there, can't you?
Yeah.
This maple tree is out there. There's that oak tree that's dying. He goes away though. And the tree line just out of range, not a problem. So in the dead of winter, those trees, their shade comes way out to here, but not quite on it.
That's just about,
What's that?
that's just about perfect.
Yeah, it works out pretty well, doesn't it? And then, of course, the other thing is that this solar panel array is going to start off the ground a little bit and go at an angle. So up here, it's going to be higher yet. I mean, as you get higher, you're going to have less of a problem,
Less, yeah.
aren't you? A little bit. Yeah.
But still, the power pole is still in there.
He's in there, isn't he? He's a little bit in there. Yeah, he's in there. Starting about 4:30 or something, and he crosses over March and September. So pretty much close to equinox, March and September, because March 21st is equinox and September 21st. Yeah, that makes sense. So right about at equinox, the pole will give us a little bit of hassle that month, you know. Likely though, he might only shade a few cells or something and take out a little bit, and it'll be for a short time.
Right.
Sometimes the other thing is that, like power lines, small lines like that, there's enough sunlight around them that they tend not to be a problem. You know, the sun it still won't shade and stuff. So, but yeah, here's the location, and Mark has already started digging some holes.
Only Mark.
Yes.
Only Mark, yeah.
We can admit that.
Starting here and then going this way?
Yep, right. So, yeah, so it's going to have, actually I have 6 posts in the ground, and then they go across here, and we're going to use a wood base because it's inexpensive.
Yep.
I had looked at pipe, galvanized the big pipe, but it's really costly, man. So Mr. Martindale had recommended I use the wood structure.
Are you gonna put cement at the bottom or the top?
Yeah, and we're gonna look at that in a minute on the drawing. How we're gonna look at the design of the structure, the framework and stuff. We'll take a look at that because Mark drew that up and stuff. And we will put concrete in the base. That's why we dug pretty good sized holes in particular because of that. And I'll show you some of that. But here's the yeah, right, but there's stuff, isn't it? Isn't that crazy? Yeah, it's like, well, yeah, it's wide open. It's the middle of the yard. How's it going to be shaded by anything? You guys remember seeing these? So there's 14 panels there. These are the 290s, and just put them here out of the way. This is called Unistrut, and we're going to be making use of this. This is really heavy-duty stuff. And we need, again, we're putting up this huge sail, 22 feet by 12, and it's just begging to be blown against. So we're going to use this big old heavy Unistrut, 3 1/4 inches tall actually. The height here is what gives it its strength. And so we'll be making a framework and structure that'll mount the panels to it from this Unistrut.
If you had a smaller one, you could do this. You can slide them in each other.
Slide it, oh yeah, for the legs, like for the
legs,
adjustability thing, like you're talking about, David. Exactly, yeah, you could do that, yeah.
But like you were saying, it's
Yeah.
better, yeah.
Yep. And so, anyway, Any questions so far or thoughts on that stuff? So then from from the panel system here, we'll dig a trench up to that little entryway there, and we'll bring the electrical into there, into the house panel and stuff.
Not too far.
No, not too bad. And as you remember, this is going to be a grid-tied system, and a grid-tied system it will go from the panels. At the panels here on the outside, we will mount, I'll show you the drawing in a minute, we will mount the inverter. Remember that big box that Mr. Martindale showed, the inverter? We'll mount that out here, so that'll change it from DC to AC here, and then onto the ground, the wires will go AC to the house, 220 volt, and they'll go in there and they'll go right into our electrical panel, and then our meter will spin backwards, which on our way back, we'll look at it. They already changed out our meter. I didn't even know when they did it, but it happened already. So we have now a digital meter that can go backwards as well as forwards in tracking. So as you recall, the panels, the width of the system is about 22 feet. Actually, we have to have a 1/4 inch between each panel for expansion and contraction. I mean, so it's got room to move. So we don't want to have them tight to each other because they can buckle and bust glass. So there's a little bit added on, 1/4 inch between each one, but there's 2 rows of panels, and then there's 3 posts in the front and 3 posts in the back. So this is the front view, which it's hard to see the structure. But you notice you talked about concrete. And so in those holes, one of the things that we're doing at the base of the holes is using a shovel to wedge out the bottom of the hole some, which makes it even a better anchor to wedge this out, and then we'll put concrete down. The posts will be set in concrete. And actually what we'll be doing is taking the bottom of the post and we'll put a couple of pieces of rebar. If you have wood and you put concrete around it, that wood can contract, and then essentially that block isn't really attached to that concrete. Although over the years when I've taken stuff apart, I've never seen a block come off a piece of wood even. It's stuck to it pretty good. But safety says if you throw a couple of rebar pieces through the wood, they grab onto the concrete and they grab onto the wood, and so then it's a better way to hold on to it. So we'll make these at the bottom of the hole. You can go to the side. Okay, so this is the side view of the structure. So the front posts are in the ground.
And the line is the ground.
The line is, thank you, Martin. And so this is going to be, lower to the ground in the front. Probably, actually, we're going to go a little higher than this 1.5 feet or so that we had planned. Because I told Mark to draw it with 2 feet. Well, that's at this post is 2 foot, but then the panel goes beyond a little bit. So the panels will extend a little bit beyond the structure. When we build these poles, one thing that we want to do is we want to integrate them together with bracing, so that they're not by themselves. Because when the wind blows against it, a couple things that can happen is it can wobble. Okay. And it can also be that if we have a post and it's all by itself and it's holding this, it's all by itself. But if I apply pressure to the top of this post, and it wants to snap maybe here, or break, or lever here, I can change that quite a bit. If I take this post and I put a brace from the top of this post down to the base of this post, then when I push on this, it's pushing on the base of that, which is against dirt and it's immovable. So it's not going to crack. So we're going to do things like that to strengthen this post. One of the things we're going to do is we're going to brace from front to back at a straight. That connects them together. Now that doesn't do much. If I got 2 posts and they're connected this way, and I push on this post, they're just going to do this together. That's really not going to help much, but it's going to strengthen the outside characteristic together, but it's not going to keep this thing going on. This brace across here, and we're going to call these bridges. It's a bridge that goes from the top of this post down to this post. That's going to, when I put pressure on the top of this post, it's going to push on that other post, but it's up here, which makes this a weak point because it pushed. Well, now if I put this cross brace back, I've created a truss. So when I push here, it'll push here, which will pull here, which will stop it, and it will move. So you're just making it so that you're making a truss. That's what's in houses. It's like this. This is a truss. So that when a load is applied in the middle down, the actual way this works is it actually pushes the load out instead of down. That's what a truss does. So we're creating a bridge here. It's also a place where we're going to rest our cross braces on. The panels, this is a panel and this is a panel. The panels are going to be attached at 2 points about a third of the way down the panel. So not on the outside edges, so in a little ways, and there's holes in the panels already, or we'll drill holes where we want them. But basically about a third of the way in. And that's that unistrut stuff. It's not drawn to perspective exactly here. And there's going to be a nut that slides into this unistrut and a bolt that goes through the panel and bolts onto it. Back up. So, and then any questions about the side? We can go to the back, which just shows a lot more stuff. All right, so get him out of the way. What did you do to him? No. Whatever. All right, so our bridge is here. On top of the bridge, what?
That's extra.
Delete him. That's what I thought. Yeah. Our bridges here are going to support the cross members that go across. Now, if this is 22 feet long, the unistrut only comes in 21-foot lengths. So what's going to end up happening is the unistrut is going to end here in the middle. It's going to be cut short. So now those pieces going across there. So there's 2 rows here, 2 rows here, and that's where the panels are going to bolt to. All right, and so very strong stuff, and yet with this much square footage, and it's like this can still flex, even though this is pretty strong. And that's what that unistrut can do. It can still flex. So when the wind pushes against all those panels, you can get it flexing. And you don't want that to happen. You don't want that to go like this. You don't want it to belly. So what we did was, we took a cross brace here that goes from the middle of this unistrut down to the post. That's just going to lock that thing in. Again, creating a truss type design right there, that triangle, and one in each way up here. Now, and then down at the bottom, we're going to do the same here. And actually, probably what we'll do is, we don't have to go to the middle and they don't have to connect necessarily, but we can come back here at an angle, do the same there, and it does the same thing. We don't have to connect these two necessarily, the middle two, because if you top and bottom, you're going to really stop from doing it. The wobble would start at the top, not necessarily in the middle so much, but on the top and bottom. If you catch that, then you'll catch it. Here's where the inverter is going to be mounted. You can zoom in a little bit, yeah. So,
Oh, that's cool.
yeah. 3D modeling, that's pretty neat. So the inverter is going to be mounted on the leg, and there'll be some other junction boxes here where wire will come in, and then wire is going to go out of this into the ground, in the ground and over to the house. So that's what's going to happen with the wiring, and we'll put the inverter on the inside because likely we might put lattice around the outside. So, yeah, go ahead.
How deep are you planning to bury the wire?
Well, wire, thank you, very good question, excellent. By code, wire needs to be at least 18 inches deep. So 18 to 2 foot is all. So it doesn't have to go that deep. And it's called direct burial. I'm not going to put it in conduit except the stub that goes into the ground on both ends. So a lot of times what you do is you run a stub of conduit into the ground and the wire in that, and then just in the dirt the rest of the way. So, excellent question though, but only a couple feet down in the ground and then it'll come across to the house. Spin around the backside. So one of the things that you have to do when you, that was a good perspective, back a little bit. Yeah, that's a good perspective. So you can see that, all the bracing and how that all works. And one of the things you have to do when you start to plan, so now we've got a design and we've got a drawing, we have a plan. Now we have to get our supplies together. There's quite a bit of supplies that are needed to make this happen because I've got to attach these unistruts to these posts. I need bolts of some kind. I need to attach these unistruts to each other, so I need bolts of some kind. You know, there's all these kind of bolting operations that I need to do to bolt things to each other. And so Mr. Martindale helped us source some through his company. He's got bolts. But we use bolts and angle braces to connect these things. You want to use something that's solidly affixed and it's not going to change, given it's getting beat up by wind. You know, things can shake loose and stuff. So we want to use lock nuts and lock washers and things. They can lock it together. So and then bolts from the panels onto these unistruts, like I said before. So that's pretty much that's pretty much the design of the ground mount system. It was very interesting. Yeah, Dave, yeah.
Can the inverter be damaged by, for instance, water, or is it sealed?
Good question. Good question. No, this is sealed inverter, meant to be outside, exterior, and be able to take water and sealed. Yeah.
Okay.
I did read some stuff that not sure about Danfoss, but from time to time, water can get in these things. I mean, they're out there in the elements, and that can be one of the faults that can happen on a solar system. In fact, Mr. Martindale just sent me an article, a research project that his company did, checking like 255 different residential home photovoltaic systems, mostly in Texas area, and they found a lot of them were ineffective, not working, or partially working, and there were a number of reasons why. One of the reasons was because of water got in and humidity and everything.
So would it be better to put your inverter closer to the panel to protect it from water?
Oh, you mean like underneath or something? Like using a panel as a roof or something? Yeah, I suppose. I mean, you could. Yeah, I mean that's certainly, you're shedding the water. That would help. That wouldn't hurt. I mean, what's the harm in that? You might as well. To some extent, we'll get some of that because this panel is going to stick out here, maybe a foot or something, Mark. I don't know what. You know, we've got a little bit of a roof.
Yeah.
Not too much from driving rain from the sides and stuff, but yeah, they're meant to be exterior. Excellent question, yeah. And so all of our junction boxes will have to have lids on them with seals and stuff like that, so we don't want water to get in to it. But.
So then it might even be better to put it on the middle post so you don't get rain from the sides.
Well, that would be true. Yeah, actually, that would excellent point. Yeah, if it was in the middle, it wouldn't get the side rain, and then you get some shielding because it's underneath the roof of the panels. You can even scooch it up closer to the panels, that even makes it better. But yeah, you know what? The less elements it gets to it, even if it is exterior, the less elements the better, because water gets in places where you don't want it to, as your dad knows from doing roofing, you know. So yeah, very good, excellent comments. Yeah, right. And it doesn't matter as much if it's on the center post or the end post, to me. Well, all I want to do is I want to have it in a place I can access it, and then I'm trying to design it in a way that I might put lattice around it to cover up the structure, you know what I mean? You know the lattice stuff I'm talking about? That might just help it, instead of having all this ugly stuff exposed, you know. So, actually, Mr. Martindale said, well, do you need a privacy fence somewhere? Because this works as a good privacy fence. It's not a good spot for us, you know, like on the south end of the property, we don't, you know, we get trees and stuff like that. You could use it. It blocks a lot of stuff. It's going to be this big thing standing out there, you know, so. Good. Any other questions or comments? Okay, well, that's about mounting and mounting systems. Oh, I would say, too, that I had, for a brief moment, had explored the pedestal mounts, you know. Oh, but they were expensive, so that wasn't going to work for us. You got to have this big column of steel and a big chunk of concrete. And it just wasn't going to be working for us.
How much do you think the concrete would cost for these 6 concrete lids?
Oh, it's nothing. I probably need to have more, but I bought 2 bags per hole. So, you know, because all we need is a concrete pad around the post. We don't need the whole hole filled up. I probably should go to 4 bags, but bags are so you can figure about $3 a bag. So I had 12 bags at $3, so I got $36. You could double it to $72. So nothing compared to the $1,000 or so. By the way, this unistrut and other things, I mean, there's not much structure there. It's $1,000 in ground mount. That's $1,000. And on the roof, it would have been maybe half of that probably. For the stuff.
Because there's just none of the bracing.
There's all the bracing and the posts and all this stuff, and so a lot more cost involved in that.
But you get the good and bad for both ways you put it.
I do like the idea there's not going to be rain coming in my roof.
Yeah.
No way, from this at least, you know.
So do you know how long your wire is running and how much your energy is actively running?
Tell me about it. What do you mean?
Voltage drop.
Oh, voltage drop. Yeah, good question. Yeah, we're running about 150 feet to the panel is where we're running. The bigger the wire, the less voltage drop. Okay, so you put your upside, bigger wire will help you. But at 150 feet or so, you really don't have that much voltage drop to worry about. When you get up, my understanding is a couple 300 feet or so, you can start to get voltage drop. But there again, you can use a bigger cable to help minimize it.
So what size of cable are you using?
This is only going to be 10-3 cable is all that's necessary.
Okay.
And that really goes by, we're taking 220, and I don't even know the amps. You remember the amps that were coming across that? Total.
Total will be the same. 7.8 would be the top, because it's gonna be this.
But remember you had 16.
Oh, because 2 strings.
Yeah, right. So we're only talking about 220 at 16 amps, so we're not talking a lot of current. So.
Okay.
Not so bad. Like in other cases, just to give you an idea, this is a pretty easy way to figure it out in your house. So a 12-2 wire, is for a regular outlet, and that can run crock pots and hair dryers and stuff, and it's 12-2 wire. It's meant for a 20 amp breaker, 12-2. And then it just goes up by 10s. A 30 amp breaker is 10-2. Okay, we're using 10-3 wire. We're putting a 30 amp breaker in. This thing is only going to be bringing in 16 amps. We've got more than enough room, right? And then a 40 amp breaker is 8. So usually 30 amp breaker would be like a dryer, like a clothes dryer. A 40 amp breaker is usually an oven. You run, say you run 8 wire to that. And then a 50 amp breaker, number 6 wire, can often be an air conditioner potentially or something like that. So,
You want to explain the second number?
the 2. Oh yeah, two conductors. Yeah, right. In an outlet like this, we have what's called 12-2 wire, which means you generally have what's considered common or hot and a neutral wire. There's also another wire called a ground in today's wiring. So there's actually 3 wires, but you call it 12-2. And I said we're running a 10-3 wire. That's because we're using 220 volt, or we're running 220 volt, 240, 220 volt. And so we've got 2 hots, or 2 commons, and a neutral, and then a ground also. So that's what we're running there. So if that makes any sense.
Okay.
Question? All right, good. All right, cool. Well, next time when we get together around the same time, and dress appropriately. I appreciate it if you want to come along, and we're going to start building it. And so we're going to have, there will be some digging. We'd be glad that Mark has dug most all the post holes. If not, by next weekend, we're kind of considering, in order to make the best use and have the most fun for you guys, is that we'll probably get the posts set in the ground. Although that's a lot of fun, digging posts. So.
No, it's not.
What?
It's not fun.
It's not fun. Okay.
It's fine.
Never mind, it's not fun. Okay. So we'll get the post probably in the ground, and then we'll start bolting together the frame and the other things. And actually, we will save you the fun of digging a trench up to the house that I have a trench and shovel. Woo! Yeah. David's excited about it. Yeah.
David dig the trench then.
Yeah. Well, yeah.
Just make a tunnel underground.
There you go. That'd be cool. Yeah. And so we'll build a structure, and maybe we, depending on how it goes, we might even be able to get some panels mounted up. If you want to come and help, that'd be great. Love it. And we'll feed lunch, and then we'll go for a few hours in the afternoon too. Now that's all dependent if it doesn't thunderstorm or rain. If it's raining or something, we're gonna have to have a rain day, because that obviously. So I guess
But
just.
it's raining.
Yeah. Oh, come on, you know. So anyway, so just plan on that if you want to help, and show up on 10 o'clock again, and we'll keep going. So, any other questions this time? Great, thanks. Well, enjoy the rest of your lovely day.
Well, actually, one more
Yeah.
question. Do you know your top pole of the wind when you're solar panels?
What do you mean? What do you mean? Like how much pressure we've got to deal with?
Yeah.
We'll figure it out quickly. Jesse can calculate it. So it's 75 pounds per square foot. And here's where, if you notice this is at an angle, so it doesn't look as big. And the height here is 8 foot 7 inches, Jesse.
Is that the 90%?
8 foot 7 inches. And then we know the dimension is 22 foot 10 inches. So that's our total square footage, and then we multiply that by 75. Good question, David.
Let's just tap away and tap away.
Wait, so we want to do 8 foot 7 inches.
Yep.
And then do that times
2210.
2210.
About 22.
22 foot. Or you could do 9 by 23 too.
Here's the top of your panels if you can see it.
That's pretty interesting.
And there's the gap, yeah, you said about the gap, a quarter inch between each
Yeah,
panel.
so that's 8.7 or 8 feet 7 inches times 22 or 22.75 times
No, 22, 2210, 22 inches. But it's fine,
It's close.
approximately.
Yeah, approximately, because then you have the gaps.
Okay.
Times 75.
Okay. And that's it. So then it'll be.
Well, just do it this way. 9 times 23.
Okay.
Because we want foot. We want
Yeah.
Yeah.
9 times 23 times 75.
That's all right. 15,525.
Pounds. 15,525 pounds is the weight, or the wind load that we have to counter against. That's why you saw us using 4 by 6 posts. And we're going to orient them the thick way with the most wind load. In other words, you know, swing around and show us that, Mark.
These are
Side view, Mark. What's that?
You made me before.
Oh, okay, well, this should be wider in the drawing here, it's not. So we're gonna do the wide way this way because the wind load's gonna be this way. So this is gonna be 6 by this way. So we've got these 3 posts with those 3 anchors countering against the wind. However, because of our truss system, we're also using the front post too. Because when it pushes on the back post, it's pushing the front post.
It'll look more like that, a little thicker post.
Yeah.
That's the normal thickness, it'll be thicker.
Yeah. So, 15,000 pounds of pressure though we have to hold against. That's a lot of weight.
So how much does yours actually hold? Because do you make it more than that, just in
Yes.
case the wind?
Yeah, and I don't know. I didn't calculate that out. Right, it would take an engineer to calculate that out. Right, I don't know what it is. But Mr. Martindale spec'd this out for me, and so it should be more than enough. Right, exactly. Yeah, you always want to go more, don't you?
Especially with your soil.
Especially what?
With your soil.
With my soil, yeah. Well, the clay soil's good. I don't have sandy soil, not like Broadhead. You know, those
Yeah.
folks over there got more sandy soil, which is good for growing some things. But
So more. Then if you're in Broadhead, you need a lot more weight.
you would need more weight, more depth, maybe more width. You know, so you're pulling more of a disc and such. So,
Yeah, that'd be-
all right, great, cool. Well, that's all I have for today.